Calling and buloluku. With whatever we do. Jioni safu no la. With whatever we do. Hale yi demunyu school. Nyepamne ne kudlukula. Nyepangi ragala gena. Nyepamne ne kudlukula. Ibuloke nongoto ni beti sola. Ibuloke dato ni betoto.
Bigi Congo.
Lamin.
Na?
Lamin te jibe norin te nyame Lamin.
Kabana wulo kono.
Wulo kono nyinta mo Lamin.
Pabilenki.
Muna ngata afamole.
Haina.
Ngata. Ngoto le. Fabrama.
Mingi. Baba nyole.
Ngoto le Fabrama.
Namu jumala kan kuma diteng.
Fabrama.
Jumala mu.
Ndele bare muso.
Lunda mana.
Kamo kata.
Jamani mbere.
Alindo ko.
Jamani.
Bari ngoto man kontande.
Bari jamani fana na ramu man kontan.
Ngoto minaka ngalamin je fom filitala. Lamin jibe nori nyala.
Lamin ila sira sama na benki. Yala so tol sayni no ko mo lokko momo.
Ngoto.
Nam.
Iterinte yalo ne Lamin hakilo diata bake karambu ngoto. Anu santeng ministry ko di ngole si suoko na amake ko be holiday la
si bitun
bagona de
ala ni ko kede namo balo
ala ni na ko na karta bulo be dam ala ni je
ngoto
nam
ngoto mon kontan feren
jamani mu ne keda
ifika Lamin ki wulo ko no nyintay mon ko do fete malo Lamin nyande sila la be la moy kala karango
jamani karamol be soron ne ko fasita wulo ko nako
karambu won ma soron ni ko karambu won soron da amake comme holiday lem ngoto dini ngo nyanta sila la ala karango la moy yamen kamen fue man kontan anda mande
alla nyin kombo kurang adanda la kombo len do la jankara mol soron do kabe kurang ma ra la kombo e ko ndol fana na karamol soron je karamol soron Lamin ada lo nyino la amanta ra fena sokon ala mu nekela
Lamin ite foi de malon kon lesinol be ke kar radio to
nga fine
e ko yana di mo Lamin ya mu na fonye
bi kabe mina kan ntambita nteri maning Fatou ntambite la sukala ala diningol bebe siri be la moyka
Fatou dan so am fana tambira jele ni subala la ngaje diningol be jet talanta nen kili waro e be seri jelet
sa Lamin farante ku kili ko keno la ba Lamin bita ka wulo ko no nyinta mo Lamin
amandara fenela
ite dine ko ni man si yakari lesinol la moy radio to e balon na
mu ne ka ke afonde ba nyara ni alon
telentel jikot
afonde ba mu de be kere
ite balon tel be cikritel ni man karambe ku kele yaje nata karana mbasa mala ya itarije
par ñarande kombo courant ho findira kombo ide nara yede ni sonka bay ko Lamin manyata la wulo ko aru karam wolbe so da fa ñembe kala
ko to wole nati ba ngal le Lamin kuntal kombo courant o ka fa me kombo courant asototal wala kinay ko e sisu kono bari ni ko e sisu kono be karangol dike la radio lin telel to hani tele masoto to nyaay man tele soto da bongo bar radio be bulen koto batterie sanga ay si ay alamo
sa do kala nyaadi
ko ta o bulaji
abe kala nyaadi
kamun ke nyaadi
radio abe wala moy la be mona falaje
ibe la karandirol kala jele
ti talle be radio ko men ka karande
ila subject no baby jele baby jele
wala nan ka coco moy fa dan so wolya ngombe tambi kan ngadi ni ngol je be ikadum bungo de ko kada maro mo
asototal de
Lamin mala be karawala de
bari
laftalal ideal on ko inde every year second wala fourth
muna ni ko nde ko folle sinila mba ndele sinlo ne ba
mba say mba foke en koto wole fango yen wulindi yalo famo keta bat yu fana bulata ko ko me yen nati jambi Lamin nyanta karana ntel beji ko be nyineka ya bulay kara wulo kana ta kilar ya bambalo yo be bulaje koto dinni ngoy si ayala le sino la moy radio
wara ka munda karam mo man soro Lamin nyanta kara si so na radio
la sila le ayala le sino
dal ko korno ko smolon
kilar ya
be ngala ko momo say mi do ni ko no kera
mengi bruzo
ndebe ko do la ba rosa no radio ba no bari woro radio ni abe jele ba do ngamra do man nembe buljan dala nyara nyar wo fara bu ko fendi mo la Lamin tayra ba rosa
bara te ku folo ajibe nori nya Lamin tamete ku
teku
bari ko do famo ke
imagine nani nyambol si zol le keje kisiki man si zol no le kafun ka nyoma bari nyambu kino ni manya na kafinde ni nambe ko zol la ga
ngale limbeta de be nyambo do dilanna
nyara ni ko rin fennat nyara nata
ko bari famo ke da
ngata bungono tambi bungono nyara ngando ko fele ko ke baru nganda ni pelo landi jak
iyo awe beter la
bungono bismillah bisu diara
ye fongo tanka sina dolu tanka koro ta koro
viewers and listeners. Welcome to another lesson on mathematics for the lower grades. And of course, this lesson to target students that are in the upper grades, in the lower basic, that is grade 4, 5, and 6. So in our today's lesson, we are going to look at word problems involving fractions. Our first question reads, Fatou used 1/4 of her new beads to make a necklace. She then used 1/6 of the beads to make a bracelet. What fraction of her beads has she used so far? I'll take it again. Fatou used 1/4 of her new beads to make a necklace. She then used 1/6 of the beads to make a bracelet. What fraction of her beads has she used so far? Okay, since this is a word problem, and we know that in solving word problems, of course, you will need to take the sentence bit by bit so that you can be able to proper analyze it and then come up with a solution. So that's exactly what we are going to do here. Let's take the sentence bit by bit. So let's start again. Fatou used 1/4 of her new beads to make a necklace. That's the first sentence. What can you make up from this sentence? Fatou used 1/4, which is 1/4 of her new beads to make a necklace. So that is 1 She used what? 1/4, which is 1/4 of her new beads to make what? A necklace. We then move on. She then used 1/6 of the beads to make a bracelet. So remember, the first fraction, which is 1/4 of her beads, was used to make what? A necklace, okay? This is used to make a necklace. She then used 1/6 of the beads to make a bracelet. So what this sentence is telling us is that she used 1/6, which is 1/6, 1/6 of her beads to make what? A bracelet. So this is going to be for a bracelet. Bracelet, okay? Now the question is asking us, what fraction of her beads has she used so far? Okay, now let's bring the two fractions together. We know that she used what? 1/4, which is 1/4 to make bracelet, to make a necklace, and then use what? 1/6, that is 1/6 to make a bracelet. Since we are asked to find the fraction of her beads that she used so far, that is automatically telling us that we want to know the fraction that is used to make the necklace plus the fraction that is used to make the bracelet. That's going to tell us what is the fraction that she used so far, the fraction of her beads that she used so far. So that is going to be addition. So we are adding. Okay? Now we have a fraction 1/4 plus 1/6. That 1/4 is the fraction of her beads that she used to make a necklace, and 1/6 is the fraction of her beads that she used to make a bracelet. So now that we have our fraction 1/4 plus 1/6, and we are to add the two fractions. But again, if you can recall on what we have been doing in our previous lesson, we know that if we are to add fractions with what? Unlike denominators, what do? We first have to rewrite our fraction. We rewrite the fractions as an equivalent fractions with a common denominator. Okay? So can we just go ahead and do that? We know that our first fraction is 1/4, where 4 is the denominator for the first fraction, And in the second fraction, we have 1 over 6, where 6 is the denominator for the second fraction. So what we need to do, we just multiply the first fraction by the denominator of the second fraction, and then we multiply the second fraction by the denominator of the first fraction. So let's do that. We'll have 1 over 4, which is the fraction of the first, which is our first fraction. 1 over 4 we multiply by the denominator of the second fraction, which is 6. We multiply the numerator by 6, and we do the same for the denominator by 6. Then we have plus. Our second fraction is what? 1 over 6. So we'll have 1 over 6. What are we going to do? We multiply this fraction by the denominator of the first fraction, which is 4. So we multiply the numerator by 4. We do the same for the denominator by 4. Now we can multiply. We have 1 times 6 will give us 6 over 4 times 6 will give us 24 plus, we move on to the second fraction where we have the numerator as 1. We multiply it by 4, and that is going to give us 4 all over 6 times 4 will give us 24. Okay. Now can we observe something from this fraction? We now have a new fraction. We have created a new fraction which is equivalent to the previous fraction that is given to us, which is our original fraction. But in this time around, when we rewrite these fractions again, we were able to have what? We were able to make sure that our denominators are the same, because that is our objective here. We want to make sure that we rewrite the previous, our initial fractions, such that the denominators will be the same, and we have achieved that. So what do we need to do from here? We know that there is a rule which says that if you are adding fractions with a common denominator, what do you do to the numerators? You add the numerators and you maintain one denominator. So that is going to give us, we'll have 6 plus 4 all over 24. So we maintain just one denominator because the denominators are the same. So when we add 6 plus 4, it's going to give us 10 all over 24. Now we have 10 over 24. Is that our final answer? No. Remember, we should always make sure that we have our answer in its simplest form. So we have 10 all over 24. We can further reduce this fraction. And how are we going to do that? We have to think of a number that we can divide both the numerator and the denominator without leaving any remainder. Okay, let's think of that number. Okay, we can choose 2, right? Because 2 can go into 10 without any remainder, and it can also go into 24 without any remainder. So 2 into 10 is what? 5 times. That is, if we divide 10 by 2, the answer is 5. So we'll have 5 all over. Now the denominator is 24. 24 divided by 2, you can further say 2 into itself is 1, into 4 is 2 times. Okay? That is to say, if you divide 24 by 2, your answer is 12. So we have 5 over 12. Now, can we further reduce this fraction? Is it possible to further reduce this fraction? Can we further reduce this fraction? 5 over 12, can we further reduce it? Do we have any number that can divide 5 and 12 without any remainder? Do we have any? No. So our final answer is 5 over 12. Now, remember, we have some options here. Options A says the answer is 1/5, that is 1 over 5. B says 2 over 3, C says 5 over 8, and D says 5 over 12. Our final answer is 5 over 12. And if you go by the options, the right answer is D, because D is 5 over 12. So our right answer is D, which is 5 over 12. So if you go back to the question where it says what fraction of her beads has she used so far? So she has used what? 5 over 12 of her beads. Okay? So that's our answer. So we move on to the next question. Okay, we have another question. It reads, it is 3/5 of a mile to Mary's best friend's house. So far, she has walked 1/3 of a mile to her friend's house. How much farther does she have to walk? I will take that again. It is 3/5 of a mile to Mary's best friend's house. So far, she has walked 1/3 of a mile to her friend's house. How much farther does she have to walk? Okay, can we take this sentence bit by bit? Let's analyze the first sentence. It says, it is 3/5 of a mile to Mary's best friend's house. And 3/5 is simply what? 3 over 5. So far, she has walked 1/3 of a mile to her friend's house. So this means that she has already walked 1/3. 1/3 is just 1 over 3. That's what it means. 1 over 3 of a mile to her friend's house. She has already gone that far. Okay? Now the question is asking us, how much further does she have to walk? Okay? So what extra mile does she have to walk to her friend's house? Because she has already covered 1/3. Right? And for her to be able to get to her best friend's house, she needs to cover what? 3/5. And 3/5 is 3 over 5. But she has already walked 1/3, which is 1 over 3 of a mile to her friend's house. So now we want to know how many more miles does she has to walk to get to her friend's house. That is what the question is asking us to find. Okay. Let's solve the problem. We already know that she needs to cover what? 3/5. And 3/5 is what? 3 over 5. 3 over 5. She has already walked 1/3 of a mile. So since she has already covered 1/3 of a mile, so what do we need to do here? What is going to be the operation? She needs to cover 3/5, which is 3 over 5, and she has already covered 1/3. So for us to be able to know how much further she has to walk to her friend's house, we need to subtract what she has already covered from the total miles that she need to take to get to her friend's house. So we need to subtract. So the operation is going to be minus. Okay? Fine. So we have a fraction 3 over 5 minus 1 over 3. Again, like we were doing, if you can observe, the first fraction is 3 over 5, where the denominator is 5. And the second fraction is 1 over 3, where the denominator is 3. So we can see that the denominators are different. So what do we need to do? We need to multiply the first fraction by the denominator of the second fraction. And for the second fraction, we need to multiply it by the denominator of the first fraction. So let's move on. So we'll have 3 over 5, which is we'll have 3 over 5 multiplied by the denominator of the second fraction, which is 3. We do the same for the denominator also, we multiply it by 3. Minus, we have 1 over 3, which is the fraction of this, which is the second fraction. We multiplied by the denominator of the first fraction, which is 5. Multiply the numerator by 5. We multiply the denominator by 5. Okay, now what do we need to do? We need to multiply. 3 times 3 will give us, for the first fraction, we have 3 times 3, that is for the numerator, we have 9 all over 5 times 3 is 15. Minus, for the second fraction, the numerator we have 1 and 5, so we multiply 1 times 5 will give us 5, all over 3 times 5 will give us 15. Okay, and this is exactly what we are looking for. If we can observe the two fractions, we can realize that the denominators are the same. What we did was, for the previous fraction, we converted into an equivalent fraction with a common denominator, and that is exactly what we have here. For the first fraction, we have 9 over 15, and the second fraction, we have 5 over 15. So already we know if the denominators are the same, what do we need to do for the numerators? If the operation is addition, we add. If the operation is subtraction, we subtract. So here, the operation is subtraction, right? So we have to subtract the two fractions. So 9 minus 5 will give us 4 all over 15. So we have 4 over 15. Okay, remember we should always make sure that we have our answer in its simplest form. Can we further reduce this fraction? Is there any number that could divide the numerator and the denominator without any remainder? Remember, we have 4 over 15. Is there any number that can divide 4 and 15 without any remainder? No. So our final answer is 4 over 15. So which means Mary has to walk 4 15ths to get to her best friend's house. So 4 15ths of a mile to get to her best friend's house. We move on. Okay, we have another problem, and it reads, Binta made a necklace that is 3.5 centimeters long. Kadi made one that is 5 3/4 centimeters long. What is the total length of the two necklaces? I will take that again. Binta made a necklace that is 3.5 centimeters long. Kadi made one that is 5 3/4 centimeters long. What is the total length of the two necklaces? Let's go back and analyze it bit by bit. The first sentence reads, Binta made a necklace that is 3.5 centimeters long. Now 3.5 is 3 whole number 1 over 2. So Binta has made a necklace that is 3 whole number 1 over 2, that is 3.5 centimeters long. Okay, so we have Binta's necklace is what? Binta's is what? 3.5 centimeters long. We move on. Kadi made one that is 5 3/4 centimeters long. Now, Kadi's necklace is what? 5 3/4 is 5 whole number 3/4. So we have 5 whole number 3/4 centimeter long. Now the question is asking us, what is the total length of the two necklaces? That is to say, what is the length of the two necklaces if they are joined together? That's very important. The total length of the two necklaces is simply what? The length, like if the two necklaces are joined, what is the length of that necklace? Okay? That's exactly what the question is asking us to do. Fine. Now how do we do that? We know that Binta's necklace is what? 3.5 centimeter. That's 3 whole number 1/2. And Kadi's necklace is 5 3/4 long. That's going to be 5 whole number 3/4. And now what is going to be the operation? Since we want to know the total length of the necklaces if they are joined together, the operation is what? It's addition. Okay? So we are going to add the two necklaces to give us the total length. Okay? The first fraction as 3 whole number 1/2, and the second fraction as 5 whole number 3/4. What can you realize from these fractions? We realize that we have what? Mixed numbers here, right? And if you can recall from your previous lesson, you were taught how to convert what? Mixed numbers to what? Improper fraction. So we are going to apply that knowledge here. Okay? How do we do that? We said to convert mixed numbers to improper fraction, you take the denominator and you multiply it by the whole number and then add the answer to the numerator. Okay? Now the first fraction, in our first mixed numbers, we have 3 whole number 1/2. So let's convert it to improper fraction. So we start with the denominator. The denominator is 2. So we multiply 2 times 3, which is the whole number, is going to give us 6. And we add that to the numerator, which is 1. So we'll have 2 times 3 will give us 6. 6 plus 1 will give us 7. So we have 7/2 for the first fraction. And we move on to the next. Now the operation is addition, so we put the addition sign. And then we move on. We have 5 whole number 3/4. 5 whole number 3/4. Again, we have to convert these mixed numbers into what? Improper fraction. Again, we do the same thing. We multiply, the denominator is 4, and the whole number is 3. The numerator is 3. So we multiply 4 times 5 will give us 20. 20 plus 3 will give us 23. So we have 23/4. Okay. Now we have our improper fractions. What do we need to do here? We know that if you look at the first fraction is 7/2 and the second fraction is 23/4. And we know that for the first fraction the denominator is 2 and the second fraction the denominator is 4. Of course we know that the two fractions have what? Unlike denominators. So what do we need to do? We have to rewrite these fractions as what? An equivalent fraction with a common denominator. So what do we move on? So we know that the first fraction is 7/2 and the denominator is 2, and the second fraction is 23/4, the denominator is 4. So we multiply the denominator of the second fraction by the first fraction. So we use the denominator of the second fraction and multiply it by the whole fraction. That is the first fraction. We have 7/2. We multiply it by 4, which is the denominator of the second fraction. We do the same for the denominator. We multiply it by the denominator of the second fraction, which is 4. Plus, the second fraction is 23/4. What do? We multiply both the numerator and the denominator by the denominator of the first fraction, and that is 2. So we multiply this by 2. We do the same for the denominator. We multiply it by 2. Okay, we move on. For the first fraction, we have, the numerator, we have 7 and 4. So 7 times 4 will give us 28 all over 2 times 4 will give us 8 plus. Now we move on to the second fraction. In the numerator, we have 23 and 2. So 23 times 2 will give us 46 all over 4 times 2 will give us 8. Okay. What can we observe from these two fractions? We can see that the denominators are the same. So we have converted, or we have rewrite our previous fractions to what? To an equivalent fraction with a common denominator. Already we know that if the denominators are the same, what do? We add the numerators and maintain one denominator. So we'll have 28 plus 46 all over, we maintain one denominator, which is 8. Okay. When we add 28 to 46, we have 70. We have 74 all over 8. Okay? Now, we have 74 over 8. What can we do here? Can we further reduce this fraction? Yes, because remember always, we should make sure that our final answer is in its simplest form. We need to think of a number that can divide both 74 and 8 without any remainder. Can we think of any number? A number? Yes, number 2, right? 2 can divide 74, and it can also divide 8 without any remainder. Okay? So 2 into 7 is 3 times, remainder 1, and that is going to give us 14. Into 14 is 7 times. 2 into 8 is 4 times. Okay? So we'll have 37 all over 4. Okay? Now we have reduced the fraction, which is 74 over 8 to 37 over 4. But 37 over 4, is it in its simplest form? No. We can further reduce this fraction. Okay? Do we have any number that could go to 37 and 4 without any remainder? We don't have any, right? So what we can do, since the denominator is 4 and is smaller than the numerator, the denominator can go into the numerator, right? So that is what we're going to do. 4 into itself is once. Into 37 is how many times? It is 9 times. 9 times, remainder what? Remainder 1. So we have 1 over 4. Because 4 into 37 is 9 times, that is 36. And when you subtract 36 from 37, you have remainder of 1, and we maintain our denominator, which is 4. So our final answer is going to be 9 whole number 1 over 4. Now can we go back to the question? Can we go back to the question? What were we looking for? We were looking for what? The total length of the two necklaces, right? That is the length of Binta's necklace and that of Kadi's necklace. So what is the total length? The total length is what? Okay, and that gives us 9 whole number 1 over 4 centimeter. That is the length of the two necklaces. Okay, viewers and listeners, that brings us to the end of this lesson, and I hope that you have learned a lot from the lesson. Until we come your way again, please stay home and then be safe.
We live in a day and age where technology is creating a world without borders, filled with unlimited potential to improve the lives of the people around us. Innovarex Global Health ushers in a new way of leveling the playing field with increased access to quality healthcare services delivered at your doorstep. Our qualified professionals are equipped with state-of-the-art point-of-care testing technology to conduct tests such as kidney function, liver function, electrolyte tests, body composition, hemoglobin, A1C, and many more services with the highest efficiency in delivering results. The addition to our flagship Wellness on Wheels, more fondly known as WOW Delivery Service, brings the entire clinical experience full circle. IGH has remained committed to creating the future of healthcare delivery. Gone are the days of sending loved ones outside the country for basic medical services. Innovarex Global Health offers a new peace of mind and takes pride in delivering the quality of care we all deserve.
In communication, connectivity is everything. We ensure that the links never sleep. Quantities and qualities, all in our data service, providing efficient, reliable voice and data service. We believe if you're not up to speed, then you're going backwards. Communications have to flow as fast as the speed of light. Whatever business you're in, having someone who understands your needs is critical. That is why we just don't offer you technology, we offer you solutions. Enjoy Gamcel's internet broadband anytime, anywhere. Your national operator, Gamcel, Yaibaram.
I get it. Albaka.
Mbaka important.
Yo, nga transfer la sto.
Ya transfer la.
Ha, code nyenje.
Okay. What's that? Nsila ID soto.
Sorry. I get it.
Bijan bro.
Albaka.
Mbaka.
Bara alla service o tariya.
Mbare.
Mo ki janna nun kunu bara tariya.
Jannom yona forest de bureau. Gambia tonkon na no mbare ya bere. Birim koyna fo kato.
Bari si kodo kino kato nim fo bolong blabe no.
56 branches mola soto Gambia jam.
Ha?
Gambia kono anin Gambia bantala bankol. Nko kono kiya bere. Kodo sifa fo falindiro fo nyaadi lafta memmen na kodi to poto nin kodi maraw. Jannom number 1 di nyonta. Andum fana nata anoda enterprise sotale. Wolam nyindi ko domorol fana kol fana be firale de dadi man domorol dir fana beteat. Gambia dawda yalo nga fa kendol sotale je.
Wo moyo diat ha.
Apelenta
baraka. Ni ma lafta nyelen kendol e bina.
Yalo bukani la ko la baraka ba.
Yalo ndel chosano lo.
Baraka.
When we touch down, get a broke down.
Gamtel G Fiber, now you can enjoy super fast internet in gigabytes. G Fiber is affordable, stable, secured, and accessible to homes, businesses, and enterprises. With Gamtel G Fiber, the future is speed. Gamtel, creating a brighter future in communication.
That's how she became mine. And see the
yara ñilla domoro ka diaten
boy jannon sikes restaurant
e say nakko be ni na dimbal nimba domoro kala janno
domoro seneyata adiyata topotoro fanan kendema bije luntan during tamala abeka domoro ki janni adi manda wala de te ka we bijele anim fanan ka fadi jang ikono e fa e ka fa minne ko pastry anim bakery iko fanan be kalele badde lomba conference lomba workshop lomba ye fo fendin lon dunia kono domoro betama nyillom international otoda number 1
amanke ba domo la jang damman
e sa domo jang is atariya
wo mu kubandi
sa nakko sa futandin
e oto sa nakko be mu sikes restaurant
ndafa na janna mu yat ni manje dorom bijam
aban
CK's Restaurant, known for best quality food and customer satisfaction.